All right, so let's get started. Let's talk about the second of the two data types. That is the subject of the chapter. The first was dictionaries, of course. The second is now sets. And there's a reason why, and I'll explain this, why it is that sets and dictionaries go naturally together. And it's very much the reason why lists and tuples go together. Now, lists and tuples are different in a certain respect. Of course, lists are mutable and tuples are not, but they're also very similar in another regard. They're both ordered sequences. Okay, you can go into a tuple, you can go into a list, you can pull out the item in index 0, the item in index 1, and so on. That's like part of the information that the list of the tuple contains. Now, with dictionaries, we found that those key value pairs, which are the elements of the dictionary, they don't have any intrinsic order to them. They're unordered. Okay, so a dictionary is an unordered sequence, or an unordered collection is a better word. Sequence seems to imply that you've got order. Collection is the better word. Okay, so dictionaries are unordered collections of key value pairs. Sets are unordered collections of whatever object you choose. Okay, with some restrictions, but we don't need to talk about that. So it is natural then to include a discussion of sets in this chapter along with dictionaries. I think the dictionaries are still like the primary topic of the chapter because they're like the data type that's really immensely useful. That's the one that you use again and again. But sets, they do come up as well. Okay, so sets like dictionaries, unordered. Okay, how are they different? Sets don't consist of key value pairs. They're just like object, 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 comma separated, of course. Other feature of sets that's absolutely essential. Sets don't allow for duplication. You can't have multiple instances of a single object inside of a set. Like, for instance, you might have the number 2, but you can't have another number 2. And that really is because sets are unordered. It makes perfect sense to have 2 instances of number 2 in a list because one's here and the other's there, right? Sets are ordered, lists are ordered, but sets are not. Because of this, you don't have duplication of elements. Okay? So just summary, and then we'll actually look at some code. Sets like dictionary are unordered collections, not collections of key value pairs, just simply objects, and you cannot have multiple occurrences of a single object inside of a set. Okay, so let's create a set. The set formation operator is the open curly brace. We should stop right there because there's a really good question. The really good question is this. This is also how you begin to create a dictionary. So why isn't this ambiguous? How does Python know that this will be a set and not a dictionary? And the answer to the question is this, is that dictionaries also contain another mandatory symbol. I'll ask, what is the other mandatory symbol that you always find in a dictionary? Yes, it's what Python uses to separate key from value. The colon, that's exactly right. So the way that Python knows that this would be a dictionary if it was about to become a dictionary is it would have colons. Sets will not. And so the set will simply be an object followed by another object followed by another object, comma separated, of course, and then close curly brace, and then there's S, and we can verify that yes, we did create a set. So there it is. S is from the class set. Just to prove something to you, the sets are unordered, so I could create another set whose elements are 2 and 3 and 1 given in that particular order. But now let us ask whether these are the same set. And Python responds true. Okay. Why are they the same set? Because they contain the same elements. Is the order different? No. Because they don't have order. Okay? They don't have order. But it printed with a particular order. Well, of course it's got to print with some order, but that's just not information. Okay. And I want to prove something else as well. I said that you couldn't have reduplication. You couldn't have multiple occurrences of an object inside of a set. So let's try to do that. That is, let's try to put 2 occurrences of 3 into the set. It seems to me possible that Python might throw an error in this case. I mean, they could have designed the language like that and said something like, be careful, you can't do that. But actually, the design decision, and I think this is the right one, so no error. But notice that we only have one occurrence of 3. And if we were to try to put another in there, and I'll show you how to add elements to a set, like nothing would happen. Okay, nothing would happen. That's very much like dictionaries as well. If you've already got a key value pair inside of a dictionary, and you attempt to add that same key value pair into the dictionary again, it just won't do anything, okay? Because like that's not new information. That's like you already know that that value is associated with that key. It's like if you say it again, it's just like nothing new. It doesn't help. So you can't duplicate elements in dictionaries. You can't duplicate elements in sets. The empty set, one might think that that would be the empty set. And of course, you would need the empty set, right? Because let's say that you decide that like a set is the right data object, data type that you need for a particular problem, right? You need to store objects, but you're not going to have duplicates, and maybe you want to ensure that you can have duplicates, and order is irrelevant. So maybe you decide that you'll use a set, okay? But very often, if you're going to build up a collection, you have to start with the empty collection. So empty set would seem to be a necessary object. That's not the empty set. What is that? Yeah, not the empty list, but the empty dictionary. That's exactly right. So I mean, it worked. Variable assignment worked. But if we look at the type of E, yeah, that's a dictionary. So the question then is this: how does one create an empty set? Well, with the call to the set function. Okay. So here we go. I'll call the set function. No parameter required. No argument is sent to it. And what set returns, if you don't give it a value, don't give it an argument, is the empty set. Okay. And that's how its length is represented. Oh, and I'll go ahead and show you this to verify that this is the empty set. With any collection data type in Python, you've got the built-in length function, let. You've got length of lists and tuples and dictionaries and strings, and you've also absolutely got the length of sets as well. And you see that the length of the empty set is 0. So yeah, that is absolutely the empty set. Okay, so one good question is this, and it was a good question about, I'll show you S again. It was a good question about dictionaries as well. It's like, how can we iterate through them if they don't have order? Well, the answer is the same here as it was before. You can absolutely iterate through all the elements in a set, but just don't assume that you will in any particular order. It might be this order, it might be that order. Do it tomorrow, it might be a different order than it was today, but you can absolutely iterate through the elements in a set. And I'll just show you. For element in S, did you know that you could write whole programs inside the console? Actually, here's what happens when you hit the run button. It takes that text file and it just feeds it line by line through the console. Equivalent to if you just simply typed it into the console line by line. But of course, text editors are immensely useful because you can edit the code. If you type in a program in the console and it's screwed, something's wrong with it, you got to do it again. So for element in S, triple dot means that Python knows that this is not complete, that it needs more. So this is a for loop. You have to indent. I'll hit the space bar once for a little bit of indentation. And then I'll just simply print the value of element. Just the simplest kind of for loop. I hit enter, triple dot again. To actually close this out so the for loop is executed, just hit enter. And there it is. Print was executed 3 times. We did iterate through the list, through the set. So you can do that. We did go 1, 2, 3, the order in which I created it, but that's just an accident. And then finally, we talked about the length function. Oh, yeah, and there's something else I want to show you as well. A very clever way to remove duplicates from a list, which is something that sometimes you wish to do. There's like the Pythonic way to do that. I'll show you in a moment. But first, a few functions that are set related. We talked about len. There's also, of course, an in function, which is a Boolean. So 1 was in S, it's 4 in S. No, of course not. There's also an add function. And what we're about to discover is that sets are mutable. So I can add in. It's not append, it's just simply add. So if I wanted to add the element 4 into S, there it is. Oh, and let me show you this. If I attempted to add another 4 into S, it's only got one 4. Why? Sets don't allow for duplication. And you can also remove. So I could go S dot remove 4. And if I look at S, S no longer has the 4 in it, so that's another example of mutation. And notice this. I had honestly forgotten what this would do until I tried it earlier today. Let's say that I attempt to remove a 4 from the current state of S, though it contains no occurrence of 4. It either does nothing or it throws an error. It throws an error. So that's one of those situations where if you need to remove an element from a set, but you don't have a guarantee at that point in the code that the set contains that element, you either ask forgiveness or you ask permission. Right? Permission would be, is that element in the set? Forgiveness would be just remove it, but do so inside of a try block. All right, and then final little bit. So let's say that you've got a list, okay, and it's got multiple occurrences of some object, multiple occurrences of multiple objects, let's say, like this particular L. It contains multiple ones, multiple twos, multiple fours, so on. Here's something that one can do. One can call the set type conversion function on L. So there is the list, but with no duplicates, okay? And you could actually carry it back to a list as well if you wanted to. That is, you could call the list type conversion on the output of the set type conversion on L, and you'd get the list 1, 2, 3, 4, 5. But again, something to be careful about. You can make no assumptions about the order of the elements that you get once it's been a set, because sets are unordered. Okay? But that is a clever way to remove duplicates. And if you don't care about order, then that's a wonderful way to do it. That's like the Pythonic way to do that. That's like how Python programmers do that. So that's the story about sets. Tomorrow I'll talk to you about the mathematics of permutations. We'll look at like the symbolism, the notation that's used in that set of functions about permutations, and then that'll be it. So like after tomorrow, it'll just be time to work.